Assalamu alaikum warahmatullahi wabarakatuh. Dear students, today we'll solve the examples of practice set 3.4 from the chapter triangle, which is based on perpendicular bisector theorem, angle bisector theorem, and properties of inequalities of sides and angles of the triangle. So, based on all these theorems which you have studied, let us solve practice set 3.4. So first example, in the given figure, point A is on the angle bisector of angle XYZ. If AX is 2 centimeter, we have to find AZ. Since it is given point A is on angle bisector of angle XYZ, therefore, this point is equidistant from point X and Z. Therefore, by angle bisector theorem, AX is equal to AZ. Therefore, but AX is equal to, here AX is congruent to AZ, therefore AX is equal to 2 centimeter. Therefore, AZ is also 2 centimeter. Second example, in the given figure, angle RST, this angle is 56 degree, segment PT is perpendicular to segment PT is perpendicular to ray ST, and PR is perpendicular to ray SR. It is given that ray segment PT is perpendicular to ray ST and segment PR is perpendicular to ray SR, which is given, and it is given that PR is congruent to segment PR is congruent to segment PT. It is given. So find major angle RSP. This angle we have to find this much. This angle RSP we have to find. Now this point lies here. It is the equidistance from these 2 points. So by angle bisector theorem, therefore by angle bisector theorem, angle RSP, major angle RSP is half the major angle RST. Now angle RST is given, therefore major angle RSP is equal to 1 upon 2 into 56. That is 2 1s are, 2 2s are 4, 2 8s are. So therefore major angle RSP is equal to 28 degree. Third example, in triangle PQR, PQ is equal to 10 centimeter, QR is 12 centimeter, and PR is 8 centimeter. Find out the greatest and the smallest angle of the triangle. Which is the greatest angle and which is the smallest angle we have to find. Now here 10 is, here 12 is greater than 10 and 10 is greater than 8. Therefore 12 is QR, then QR is greater than length PQ and PQ is greater than PR. Therefore by theorem, angle opposite to greatest side is greater. Therefore, this is the greater side. QR is the greater side. So angle opposite to the greater side is angle QPR. Therefore, angle QPR is greater than angle opposite to PQ. Angle opposite to PQ is angle PRQ. Angle PRQ, and angle opposite to PR is angle PQR. Angle PQR. Therefore, angle QPR is the greatest angle, and angle PQR is the smallest angle. Fourth example, in triangle FAN, angle F is equal to 80, angle A is equal to 40 degree. Find the greatest and the smallest side of the triangle. State the reason. So now if you see here, in this triangle FAN, two measures of two angles are given. So you have to find first the measure of the third angle. Now we know that in triangle FAN, the sum of measures of angles of triangle is 180 degree. So sum of all three measures of the angles of the triangle is 180 degree. Therefore, major angle F plus major angle A plus major angle N is equal to 180. Now angle FN and A are given. We have to find N. So 80 plus 40 plus major angle N is equal to 180 degree. Therefore, 80 plus 40 is 120 plus major angle N is equal to 180. Therefore, major angle N is equal to 180 minus 120, which is equal to 60 degree. So angle N is equal to 60 degree. Now, out of these three angles, 80 is the greater, 80 degree is greater than 60, and 60 degree is greater than 40 degree. Therefore, angle F is greater than angle N, and angle N is greater than angle A. Now by theorem, side opposite to greatest angle is greater. Side opposite to greatest angle is greater. Therefore, here side opposite to F is side AN. AN is greater than side opposite to angle N is AF. AF is greater than side opposite to A is FN. So therefore, side N is greatest side, and side N is greatest side, and side FN is smallest side. Fifth example, prove that an equilateral triangle is equiangular. Now let us consider given thing, given triangle ABC is an equilateral triangle. What we have to prove? To prove triangle ABC is equiangular, means all angles of equilateral triangle are congruent. Here we have, it is given that triangle is equilateral triangle, so sides of the equilateral triangle are congruent. So AB is equal to BC is equal to AC. It is given to us. We have to prove that angle A equal to angle B equal to angle C. Okay. Now in triangle ABC, side AB is congruent to side AC. Since sides of equilateral triangle are equal, equilateral triangle are equal. Therefore, by now two sides are equal, so by isosceles triangle theorem, the base angle opposite to the congruent sides are congruent. So therefore, here angle ABC, therefore angle side opposite to this AB is congruent to AC. So angle ABC is congruent to angle ACB. Angle ACB, number first. Also side AC is congruent to side BC. Sides of equilateral triangle are equal. Therefore, by isosceles triangle theorem, when two sides of the triangle are congruent, then by isosceles triangle theorem, this angle ABC is congruent to angle BAC. Angle BAC is number 2. Now see 1 and 2. Angle ABC is congruent to ACB. Angle ABC is congruent to angle ACB, and ABC also congruent to BAC. So all three angles are congruent. So from 1 and 2 we get here angle ABC is congruent to angle ACB is congruent to angle BAC, that is angle ABC is equal to angle ACB is equal to angle BAC, that is angle B is equal to angle C is equal to angle A. Therefore, we have proved it that therefore triangle ABC is equiangular. Hence we have proved it. Example, prove that if the bisector of angle BAC of a triangle ABC is perpendicular to side BC, then the triangle ABC is a isosceles triangle. Now let us consider triangle ABC here, and AB is the bisector which is perpendicular on side BC. So here there is formation of two triangles. So let us consider in triangle ABD and triangle ACD. In this both the triangle, angle BAD is congruent to angle CAD. CAD. Angle BAD is congruent to angle CAD. This, since this is the bisector, it is given. Angle bisector. So angle bisector divides the angle into equal measures. So these two angles are congruent. Then side AD is congruent to side AD. Side AD is in triangle ABD as well as in triangle ACD. So it is a common side. Now angle ABD, as this AD is perpendicular to BC, so this is 90 degree as well as this is 90 degree. So angle ADB is congruent to angle ADC. Angle ADC, each 90 is given perpendicular. Therefore triangle ABD is congruent to triangle ACD by angle side angle test. Angle included side and angle test of congruence. They are congruent. Therefore side AB is congruent to side AC, corresponding side of congruent triangle. Since these two sides are congruent, therefore triangle is isosceles triangle. Therefore triangle ABC is an isosceles triangle. In the figure, if PR is congruent to PQ and you have to show that PS is greater than PQ. So let us consider in triangle PQR. In triangle PQR, segment PQ is congruent to segment PR. Two sides of the triangle are congruent. Therefore, by isosceles triangle theorem, side opposite to congruent, angle opposite to congruent, side is congruent. So here angle PQR is congruent to angle PRQ. Number first. Now angle PRQ is an exterior angle of triangle. This angle PRQ is exterior angle of triangle PRS, Therefore, by exterior angle theorem, measure of exterior angle is greater than one of its remote interior angle. So angle PRQ is greater than angle PSQ. Now from 1 and 2, see PRQ is greater than PSQ, but this PRQ is congruent to angle PRQ is congruent to angle PQR. Therefore from 1 and 2. This angle PRQ is equal to angle PQR is greater than angle PQR is greater than angle PSQ. That is, this angle PQR is equal to angle PQS. That is, angle PQS is greater than, and we can write this angle PSR as angle PSQ. You can write this PSQ, that is Q dash R dash S. Therefore, now this angle is greater than this angle. So here by theorem, side opposite to greater angle is greater. Therefore, side opposite to PQS is segment PS is greater than side opposite to angle PSQ is segment PQ. Hence, we have proved the in the given figure in triangle ABC, segment AD and segment DE are the altitudes. These are the heights on BC side BC and side AC altitude such that AE is equal to BD. It is given AE and BD are equal. You have to prove that segment AD is congruent to segment BE. So now let us consider triangle AEB, triangle AEB and triangle BDA and triangle BDA. In these two triangles, angle AEB is equal to angle BDA is equal to 90 degree. Hence, both are right angle triangle. This is one right angle triangle, ADB and AEB. Both are right angle triangle. Therefore, in these two right angle triangle, side opposite to 90 degree is called as hypotenuse. So, both the triangles hypotenuse is 80 for triangle ADB as well as triangle AEB. The hypotenuse, so hypotenuse AB is congruent to hypotenuse AB, common side, it is common side in both the triangles. Also, segment AE is congruent to segment BD, that is given. It is given here A is equal to BD. Therefore, triangle AEB is congruent to triangle BDA by hypotenuse side test. Hypotenuse side test, they are congruent. Therefore side AD, segment AD is congruent to segment B, that is corresponding side of congruent triangle. Hence, we have proved it.